All right, welcome to this first video for Unit 4, which Unit 4 is about the periodic table. And during this first unit, we're going to learn a little bit of the history of the periodic table, and we're going to learn a little bit about why it's organized the way that it is. Now, if you take a look at your screen there, you'll see that this is one of the early periodic tables that was developed by scientists in the past. And so we're going to talk about kind of how this periodic table actually kind of looks like the periodic table of today. We'll talk about that later, but how this was developed and the way it was organized. Now, the first scientist that we're going to talk about is Dmitry Mendeleev, and he originally organized the periodic table by atomic mass. Now, if you take a look at the periodic table, if you take a look at the atomic mass on the bottom, you'll see that generally it is actually ordered by atomic mass. And so it goes from hydrogen, which is the lightest, all the way to the heaviest. However, there are many exceptions to that. And if you look at your periodic table, you can see some exceptions where it's not in order by atomic mass. Now, one thing that's really interesting is he also organized it by property, by their properties. And what he noticed is that there were actually elements that were missing on the periodic table. And he was actually able to predict those missing elements, and he was able to predict their properties even, which is actually a really cool thing. And so we'll talk about that in a little bit here. But if you take a look here, this periodic table is similar to our periodic table, but it is rotated 90 degrees. You can see that the first column on the periodic table has lithium, sodium, potassium, rubidium, and you'll see that kind of towards the bottom there, you'll see that that first column is actually a row on the periodic table. Now, if you take a look, there's actually a couple elements that have question marks on them, and that's because back when this was developed, those elements were not discovered yet. And so what Mendeleev noticed is that there were certain elements that were missing on the periodic table, and he was able to predict what those elements, how they would behave, and he was even able to predict where they would be and about what mass they should be. And so it's really interesting stuff. And so you can see that this is the periodic table rotated, so that same periodic table but rotated there. You can see fluorine right here, chlorine, bromine. These are all the halogens. You can see that these are this is the first column, and then we have the oxygen column, nitrogen column, carbon, boron, and so on. So it's really, really interesting. All right. So again, Mendeleev did it by atomic mass, but Henry Moseley came along and he arranged it by atomic number. And this is actually how it's arranged today. Atomic number, again, tells you the number of protons, and he realized that some of the elements were out of place, and so what he realized is that it actually should be by atomic number instead of atomic mass. And so each small square on the periodic table shows the name and basic information of an element. That's nothing new to us. And here are some general information that you'll find on the periodic table. So you'll see the symbol, the name, the atomic number, and the mass number, or the, well, not mass number, but rather atomic mass. Now, the vertical columns of the periodic table are called groups or families. So we call, again, each column, we call them a group. Or a family. And if you take a look, for example, the first column there, we're going to learn that those are the alkali metals. Those tend to all behave the same. They have the same properties. The second column, which is the alkaline earth metals, those tend to have the same properties as well. And it goes, that trend occurs throughout the whole periodic table, even to the last column there where the noble gases all behave the same. You'll see that each group contains elements with similar chemical properties. And the reason why they have similar chemical properties is because they all share the same number of valence electrons. It's actually the valence electrons that determine the way that a chemical reacts. And so now the horizontal rows on the periodic table is called a period. And the reason why they call it periods, and the reason why the periodic table is called the periodic table, is because what was discovered is that properties will periodically repeat themselves. And so, for example, the alkali metals all are really explosive in water. The halogens are toxic gases. The noble gases are non-reactive gases. And what was observed is that as you ordered the elements, you would see that properties would periodically repeat themselves. And that's where the word periodic table comes from. And so each row on the periodic table is a period. Now let's talk about metals and nonmetals. All right, so a metal is classified as an element that is a good conductor of heat and electricity. So metals can conduct electricity and they conduct heat very well. It's why we use metal to create pans that we cook with. Now, if you take a look at the periodic table on the right there, you'll see those teal elements, and you'll see what is called the staircase. And the staircase is what divides the metals from the nonmetals. Everything to the left of the staircase is a metal. Everything to the right of the staircase is a nonmetal. Now, most metals are malleable and ductile, and the reason why the word most is used there is because there are some that aren't so malleable. But malleable means you can bend. Ductile means you can stretch into a thin wire. And they're also lustrous, which means they're shiny. Now, alkali metals are highly reactive metals in the 1A column. So the first column on the periodic table, those are alkali metals. And these are just some general properties or characteristics of those alkali metals. We'll actually get into more detail with some of this in a future unit, but they do form a 1+ charge. Again, we're going to learn about that later. They form peroxides. Again, we'll learn about that later, but essentially a peroxide makes the formula X2O2, like hydrogen peroxide is H2O2. Again, we learn that later in a future unit. They form ionic bonds with nonmetals, creating salts such as sodium chloride, lithium chloride, potassium fluoride, so on. They also combine with hydroxide, which OH is hydroxide, to form strong bases. Again, these are all things we're going to learn later, and they react violently in water to produce hydrogen gas. And so we'll see a cool video on that in class. And so again, that first column on the periodic table, lithium, sodium, potassium, rubidium, cesium, francium. Those alkaline earth metals are metals in group 2A. So they're metals in group 2A. And so they're in the second column. And so the way that I kind of remember it is alkali has one word, alkaline earth has two words. So alkali is the first column, alkaline earth is the second. Now these are general characteristics of those particular metals, and we'll learn about those in the future, but they form a 2+ charge. They form oxides. They make ionic bonds with nonmetals to create salts as well. And they do combine with hydroxide to form strong bases. And so there's actually some similarities with alkali metals there in terms of them creating salts and all that. They do form a 2+ charge. Again, this is going to be a future unit that we learn that. So again, the second column there, the beryllium, magnesium, calcium, and so on, those are alkaline earth metals. Now, the transition metals are the metals that are between the 2A and the 3A. And essentially, it's all the pink elements that you see on the periodic table there. So the pink ones are called transition metals. And so a nonmetals are classified as elements that are poor conductors of heat and electricity, so they don't conduct heat or electricity that well. Again, the staircase there, everything to the left of the staircase is a metal. Everything to the right is a nonmetal. And we're going to learn a little bit that those teal ones are actually metalloids. And so here's some examples of nonmetals. We got sulfur in the back. You can see the yellow carbon and chalk. I'm assuming that's chalk. But anyways, most non-metal solids tend to be brittle. So they tend to be brittle, which means that you can easily break them, kind of like peanut butter brittle, like that. So that's brittle. The group 7A, or where the halogens are, these are extremely reactive. And if you take a look, the 7A has fluorine, chlorine, bromine, and iodine. You'll see that those are all halogens. They're all very, very reactive. They are nonmetals. and they are in the 7A column. They all have 7 valence electrons. And then group 8A are elements that are known as noble gases. They are relatively unreactive, or they are said to be inert. They don't really react. We'll learn about that later, but essentially it's because they have a full octet. We'll learn about that later. So again, that last column are the noble gases. So what I will say is, this is what you need to know. You need to know that the first column are alkali metals, then alkaline earth metals. Then we have halogens on the 7A column. Then we have noble gases on the 8A. Everything to the left of the staircase is a metal. Everything to the right is a nonmetal. Hydrogen, however, is an exception. Everything to the left of the staircase is a metal for the exception of hydrogen. Hydrogen is actually a nonmetal. So that's actually going to be very important for the future. All right, and then we have metalloids. We won't really get into metalloids too much in this class, but they are classified as an element that have some characteristics of both metals and nonmetals. They're essentially the elements that are the teal blue there. They're right on the staircase. They're right in the middle of metals and nonmetals. Metalloids tend to be great semiconductors of electricity, and that's why they're used in like battery technology and whatnot. In fact, Tesla is doing some really cool stuff with silicon batteries right now. And then there's there's Hofbrinkels. We've talked about them several times before, but we want to remember that Hofbrinkels are elements that when they are alone by themselves, they don't exist as just one atom, but 2. And you can see, you can locate those on the periodic table there. But that's essentially an overview of the periodic table. Make sure you have the different family names, alkaline metal, alkaline earth metal, and so on. Make sure you have those down. Make sure you know what the difference between a metal and a nonmetal is, like where they are on the periodic table, and that they're divided by that staircase. And then make sure that you know the scientists. Mendeleev organized it by atomic mass, which is not correct, but pretty close. He also organized it by chemical property. Then Moseley came around and he organized it by atomic number because he realized that it wasn't quite right. Make sure that you are just familiar with the overall structure of the periodic table. That's all we have for this particular video. I hope you have a great day and take care.